Hello students, welcome back to the class. Can you just make some noise? We'll spend the rest of this lecture.
हाँ नहीं लग रहा है नहीं लग रहा है कहने ठंडा है तो बहुत भारी है दो ठो जैकेट पहने
Hello.
दो ठो जैकेट पहने ठीक है दो चप्पल पहनिए दो जैकेट
We'll spend the rest of this lecture talking about databases. We have been talking about databases, but talking about NoSQL databases and types of NoSQL databases. Okay. So, so there are four, 5 key types of databases when you talk about NoSQL databases.
नहीं रे
First type is document oriented. This is the type we are going to use in our project. Second is key value. Third is wide column or column based also. It's called as column based. Fourth is graph. And there's one more called as time series, but we will not discuss that. It's not needed for this class. There's also time series. This is like click stream, etc. When you get time series or maybe stock market data you get, that is time series data. So what is document oriented databases? You have basically a database where each row is a document that you save. This is very similar to what you have seen previously. Basically, you have a bunch of objects. Each object has an ID and there's an object associated and a value associated with it. And the document oriented database will be just a database containing all these objects. Whereas key value pair is very similar to document oriented. There will be a document here. Okay, so we'll come to key value in a few minutes. Let me see when you should store. Let's look at some of the popular document oriented databases. There is MongoDB, which we are going to use. There is CouchDB. There is DynamoDB. There is Google Cloud Data Store. Google Cloud Data Store. And there are a few more, but these are a couple of most important. MariaDB is one. MariaDB is not documented. It is probably column wide. I'm not sure. MariaDB. Let me check. Just give me 1 second. MariaDB. It's a relational database. MariaDB is a relational database. It's not column document oriented. It is so there was one time when people were thinking MySQL will become non-open source, and at that point people developed MariaDB, which is a relational database. Okay, Ekta? So I was under the assumption it was NoSQL. No, MariaDB is a MariaDB. You can Google it. MariaDB is a most popular open source SQL. It's based on MySQL. Thanks, sir. Okay. There's a penguin whose image comes when you click on MariaDB. Yeah. Okay. Key value pair. So when should you use document-oriented databases? When you are working with semi-structured data, there is some structure in data, but there is not clear structure. For example, JSON or XML data. Then you can use object-oriented. You're not sure about what kind of schema you will use in your app. You are just building the app initially, and mostly for all the pet projects where you are not sure what you are going to do with the app later on, you can start off with document oriented. It's a very versatile database, and you can use anything inside that document. Essentially anything you can do with the document. So document DB is and it scales fast and it is highly available. So it's a very good database. Couple of companies that use, have you heard about Coinbase? Have you heard about Coinbase? Coinbase, yeah, Kuber. It's very similar to Kuber. Coinbase is basically a cryptocurrency exchange, and what they do is they use MongoDB to serve bunch of requests. That as their database, they use MongoDB. Okay. Similarly, Sega uses MongoDB at the backend. Sega is gaming company. There's a Sega gaming company. You might have played some games on Sega. Yeah, Sonic is a game from there. Yeah. So Sega uses MongoDB at the backend. Now let's look at graph databases. What is graph database? Have you? So basically, what happens in document oriented is you are saving objects into the database. That is the basic idea that I want you to remember. You are saving objects into the database. With graph, you are saving graphs. Okay. With graph databases, you are saving graphs. Sometimes, so what happens is when there are a bunch of relationships in the database and you save it in relational database, then you'll have to do a lot of joins to get a database. Suppose you want to do breadth first search on a given point. What do I mean by that? Suppose there is a friends graph on Facebook. Everyone is friends graph on FB, Facebook. Now what will happen is if I want to do a breadth first search on a friend, it will require a lot of joins on the table. And since the table has 3 billion users, it will be almost impossible to do a breadth first search using relational database. But do you know what breadth first search is? I have discussed it in my graph lecture. So some of you might not know about it. Breadth first search is when you have a graph database. It is a level-wise traversal of a tree. Okay, similar to level-wise traversal, or even if you want to do DFS on graph using relational database, it's very difficult. But with a graph database, what you do is you save the adjacency list or adjacency matrix into the database, and then you can do a basically graph search or graph traversal. Whenever you have these kind of relationships, you can use them. So when Walmart uses graph database for product recommendation, Walmart, when it recommends products to people on its website, it actually uses a Neo4j database for recommendation purposes, which is a so in a graph database you can easily do recommendation based engines. Does that make sense? Am I talking a lot of gibberish? Vivek, are you following? Do you remember the graph lecture, Vivek? And do you remember how to do DFS and BFS on graph? In graph database, you just save that whole data structure into the DB. Direct DB will contain the graph. Walmart uses it. NASA also uses. If a project that's a very good question, Avijit. A project can have multiple types of DB. It's not. I'll discuss white column in few minutes, but let me comment to Avijit. A project might have different requirements. Some of the databases might be object oriented. Some mini service will be some mini service will microservice will be using a key value pair. Some microservice will be using a graph database, and this is an industry norm. There will be multiple databases which will be used in a single application. How do they communicate? How do different services communicate in a application, Abhijit? APIs, exactly. So these databases also hide behind APIs and they communicate with each other. I'm going to discuss column wide in a few minutes. I've not discussed it yet. Meta has all the databases. It will have graph database for friend recommendation. It will have column wide for user details. It might have key value for the caching part of it. So it will have a combination of all of them. Okay. And Amazon also have a combination of all of them. Typically inside a particular team also in Amazon, there will be multiple databases which will be used. Graph. Okay, Suraj. Graph database. Do you know what are graphs, Suraj? Have you do you have any idea about graphs in DB databases or data structures? Have you ever heard graph data structure? Okay, so what graph database is? You just save that data structure into the DB directly, and that is called as graph DB. Okay. Now on top of that, you can do breadth first search, depth first search, all topological sort, all kinds of algorithm that you can run on your normal graph data structure. You can run on this database also. Does that make sense, Suraj? Yeah, they use so no, Ekta, it's not like this. They use API to communicate, of course, but they have a very simple API and it's very simple to write to these databases. But typically what will happen is one database will be attached to a server, a server for a mini microservice, and this microservice will be communicating with another microservice with a separate database. This will be one way. This will be server 1 and this will be server 2. Sometimes this server might be attached to two DBs, DB1 and DB2, which have different technologies involved, but it will be combining the data from these two in different ways. Whenever this has to communicate with this, it will go through the server. Okay? Okay, Suraj? So server will be the brain that will communicate. DB will only be like a storage device which will store whatever you tell it to store. And these DBs are basically, does that make sense, Ekta? Okay, sure. So where was I? Column wide. So graph is clear then. Now let's talk about key value and then I'll talk about wide column. Key value is basically, do you remember the queue implementation that we have done in class? Queue implementation. Can somebody tell me how did we implement a queue in our data structures course? First in, first out. That is true. But what was the implementation? Which structure did you use for implementing it? We used an array and a linked list. We used two stacks, array. No, we used something different. Do you want me to share the screen? Linked list? No. Linked list can be used, but we use something more advanced than linked list. Okay, I'll share. Just give me 1 second. We don't use two stack. We use an object. That is correct, Gauri. So we can use the map to implement a queue. We can use a map with starting index and ending index, and then every object will have an index and we can move around on the map. So this is how we can implement a queue using a map. You will have a map which will contain indexes 1, 2, 3, 4, 5. One will have some value, say 1 will have value A, 2 will have B, 3 will have C, 4 will have D, 5 will have E. And then you know that start index is equal to 1, end index index is equal to 5. Whenever there is a push operation, suppose I push f into this data structure, I'll create another number f6 and I'll make it f, and I make my end index as 6. Suddenly I'm able to push to the end of the linked list, end of the queue, and whenever I have to pop something, pop, I can make the start index as 2 and I can delete this guy. So this way you can implement a queue using a map. Do you remember this? Vivek, do you remember this? Students who have not attended my Q class can remember this. Can you understand? Is there somebody who has not attended my class on Q uh, and is not able to follow this? Suppose this is my Q. I remember this by an index, and whenever I want to push something, I push at the end. Suppose I want to push X, I push it like this, and if I want to pop something, I pop from the starting. And I make my start index and an index change over time. A start index will become 3 and an index will become 7. That's how I can code up a queue using a map. So now coming back to the key value pair. Sometimes you need a lot of DQ will work here. DQ will work like this. DQ is pop. DQ is pop. Okay. DQ is basically just remove the lowest index and remove its data from the queue. Okay, key value pair can give you queue data structure. So what you can do is, if you have a service queue that you want to implement, you can use a key value map. Okay, caching, persistent state, all those kind of things where you want to store a key and a value. For example, here also key value databases is basically a map that you store. And whenever you want to store a map into your DQ, sorry, DQ, yeah, DQ, sir, sorry, DQ, doubly-ended queue can also be implemented using a map. That is completely possible. Vivek, DQ will work, a normal queue will work, both of them will work. Okay, so whenever you want to store a map, you can use a key value pair database. There are a bunch of them. There is Redis, there is Hazelcast. You might have heard about React. There's Voldemort, there's Memcache, there are a bunch of them. Redis is the most popular in terms of you might have heard about Redis queue, which is basically the same idea that I have drawn here. You will have a queue data structure that is implemented using a map, and it is saved in the DB. Whenever you have, so why do you need this kind of key value database? Suppose you have a service and you are encountering a lot of requests on your server. Your server will not wait for all the requests to come. It will keep a queue, and in the queue you will insert your request, and server will keep on solving the request in the queue. If there are too many requests, they will go into the queue. If there are too few requests, they will and the queue will be empty. Okay, this service queue is what is used in what we use as Redis. Redis queue is nothing but a service queue. Okay, this is your server. So that is key value pair. Now, last but not the least, let's talk about the wide column database. Difference between object oriented and key value. Object oriented is typically the internal things are different, but basic difference that you can think of it between these two FGs is the difference between object and map in JavaScript. You know, uh, there's a subtle difference. You can do both of them can do the same thing. A object can do what a map can do, and what a map can do can be done by an object. What a object can do, can a map can also do. But the good thing is, map gives you some more capability, and object gives you some other capabilities. When you have a lot of unstructured data and you're not sure how you are going to exactly use it, then object is the way forward. Key map uses map. Key value uses map. Yes, it uses map, Karan. Exactly. And whereas object oriented is uses bunch of objects. Yeah. There are few implementation details that change, but overall object oriented is similar to objects. Document oriented is similar to objects. Redis and Hazelcast. Redis is basically a queue. So Redis is basically a key value store. It is a map that is stored in your data in your storage. It is not in your RAM. It is a database that stores a map. And then there is Redis queue, which is used by servers while they are getting client request. When you send a request to your server, it does not directly go to the server. It first goes to Redis queue, and then Redis queue, the server will read request from the queue in first in first out manner. Okay, Suraj, that is what Redis do. Redis queue do, and Redis is basically a key value store, and Redis queue is the implementation of a queue data structure using the map. Okay, Hazelcast is another key value store. React is another one. There is few more. This Memcached is also there. So a bunch of them. One beautiful use case of key value store is when you want to store a cache. Okay, suppose you want to store a cache, you will have some pages that you want to remember because you are using them again and again. So what you can do is directly give them an ID and store them in your cache. So React is typically used in caching. Okay, so let me show it to you how this will work. How caching works, let me show it to you. Suppose there is a server which has a DB. Okay, or there's a DB. Okay, and there is another server. I'll just call it client. Okay, client request before going to the server goes to a cache, and request will have an ID. And a client, when it requests the cache, if the request is present in the cache, it will come back from the cache and it will not go to the server. But if that value is not stored in the cache, it will go into the server, taken from the DB, and then sent back to the client. So every client have two options. Either it can go to the cache or it can go to the server. This cache will be, cache is also a server. Yes, cache is also a server, but I'm calling it cache for the time being. Like, cache can be anywhere. This is also a server. This client is also a server for somebody else. Like, client and server, it is not the final client, but it is a server which is taking value from a given server. Before getting it from this server, this request will first go to the cache, and if cache already has it, it will return that. This cache will have a request ID. Request, yes, we have to create that. Yeah, you don't have to create it, but yeah, that is what typically happens in the industry. You have caches all over the place. Whenever there is a server, there's also a cache which replies faster than the server. Okay, so there will be a request ID with the corresponding response, and this will be a key value store. Okay, so every request ID there will be a response and it will get sent all the time. So when you have to implement a cache, it's a good idea to use a key value store. That was the point I was trying to make, Deepak. Okay, does that make sense? Confused with cache server? Okay, just give me 1 second. Mm. I'll explain. Don't worry about it, Vivek. Cache server. I'll explain. Suppose this is your backend server. This is your client. This is where the machine which is running your computer, this is the machine that is running your browser. It sends a request to the backend server. This backend server needs some data. Where will this data go? This backend server will communicate with a cache server. If the value is not in the cache, then the cache will communicate with database server. And get the value from the database. What this cache is doing is, for every request which has come recently, it is remembering the response. And this request and response forms a key value pair. So you save the request and response, a table of request response, into this cache. And whenever a request comes, you send the response. So when you implement a cache, what you need is a key value store. Does that make sense, Vivek? Okay. Deepak, is this making sense to you? The cache server? How it is working, what it is? Deepak, Yashwant? Do you want to unmute? Okay. Deepak, Yashwant? Deepak, can you unmute yourself? I want to just hear out your question. If that's possible, can you unmute yourself? You can't unmute. Okay, let me see. But cache is the server, right? There is not a difference between response of same request based on different users. Yeah, that is not. I mean, the request will have a request ID, and typically when the same request comes, then only you respond. Okay. So every request will have a unique request ID. If the same user requests the same thing, then only you respond with the same thing. Okay. I'll tell you an example of this. Suppose Michael Jordan. I don't know why Michael Jordan is coming again and again. Michael Jordan makes a tweet, and this tweet will be saved in that database server somewhere. Okay. And what will happen with this tweet is, since it is such a popular tweet, it will be saved in a lot of caches that are present near the locations of people that are viewing that tweet. Okay. So now this tweet will have a tweet ID. And tweet ID and tweet will be saved in this cache server. Every time somebody wants to get this tweet, because this is being accessed by different users, it will go to them very quickly from the cache. Does that make sense, Likit? Okay. So all the most common things are going to be saved in the cache, so you can get them quickly. Cache is basically a simple key value pair. It does not do anything other than that. And you can have a very small cache at different places, and then cache will boost up your latency, reduce your latency and boost up your speed, because it's a very fast database, and you can have a small database at different places. Does that make sense, Deepak, now, or do you want me to explain again? I can explain again. Don't worry, Deepak. Do you want me to explain again? Yes or no? Okay. Okay, Deepak. Deepak, do you know about caches? Do you know what caches are in your computer? Have you ever taken a course on operating systems or something where they would have taught you about caches in computer? Okay. So in computer, what happens is there is a storage, which is a slow machine, and there is a cache. And whenever you need some page from the storage, first it goes to the cache, and then it comes to the CPU or the RAM. Basically, it comes to the RAM. When a page has to be loaded into the RAM, it first goes to the RAM first checks in the cache. If it is present in the cache, it will load from the cache. Otherwise, it will load from the storage. This is the basic process that happens in any computer. In distributed system, this same process is then replicated into multiple machines. Cache server will be a separate machine, database server will be a separate machine, and backend server will be a separate machine. That is the only difference that is occurring here, Deepak. Rest everything remains the same. There's a different machine given to cache. Okay? And that machine typically runs a key value store. Key value store. Okay. Thanks, Deepak. It always makes me happy when some students' doubt get clear. I cannot tell you how much happy you make me. Okay, so column-wide databases. This is another way of storing data. And how do I put it? Have you ever had a request where there are users and you want to find the average age of the user? If you ever do business analytics, they will teach you a lot of SQL, because business analytics, the core of business analytics is SQL. Also in SQL, what they do is they do a lot of these kind of queries: average age, max age, min age, standard deviation in the age, all those kind of aggregate functions that you apply. Okay. So you will have a SQL database which will contain maybe student and age. And now people will ask different kind of questions about age. Business analyst will ask what is the mean age of a student, who is the youngest student in class 8, who is the oldest student in class 8, what is the average grade of students who are born in January, what is the average grade of students who are born in December. All those kind of statistics people will be asking about a table. Now in SQL, these statistics make sense. They are easy to do. But sometimes what happens, there are applications, for example, Netflix, which needs a lot of data, which needs to do a lot of data analytics on a huge amount of data. And suddenly this table is like, since it is SQL, you cannot have it on multiple servers. You cannot horizontally scale it. So what is needed? The need is to do analytics across rows. You need to do across rows or on columns. You need to do analytics on each of the column in the database. And for this, you cannot use SQL database because suddenly you cannot horizontally scale it, and application or Netflix cannot run on a single machine. Application like Netflix cannot run on a single machine. So what they do actually is they store it in column wise manner. They store it like this. Age, the whole age is going to be stored as an array in a database. And then students will be stored in a different, as an array. Student will be stored like an array. There will be a student array, there will be an age array, there will be an ID array. All of them will become arrays. And these arrays will be stored in different machines. Okay. And then you can do analytics on each of these. You can do analytics on age, you can do analytics on student, you can do analytics on ID, so on and so forth. Aradhya? Like what? Okay, so I'll explain it one more time. So, why to store like this? Because you want to horizontally, because most of the analytics that you want to do is on per column basis. So you don't want to do analytics across columns. So you store them per column basis, and then you can horizontally scale it. You can store one column in one machine, second column in second machine, and then you can do map reduce kind of stuff on these columns. Have you ever used map or reduce on your array? So now you can do map and reduce is something that can happen in a horizontally scaled manner. So suppose you have a bunch of machines, you have a bunch of like 5 machines also. If the array is spread across 5 machines, then also you can do map and reduce. Now Netflix might ask a question like, what is the average watch time of users? What is the average watch time of users in India? So there will be a array which is going to be, yeah, I'm showing the example. Okay, I'll show the example. Just give me 1 second. So I'm taking the example of Netflix. Now Netflix might have a use case where they want to find the average watch time of users. And then what they want to do is they want to access this data every day. Every day they want to use what was the average watch time today, what is the average watch time tomorrow, what is the average watch time on Saturday, what is the average watch time on Friday, all those kind of data. They want to have a graph of this. Is the use case clear? They want to have a graph of average watch time. Okay. Now, the question is, since Netflix have a lot of users, imagine they have so many users that you cannot do it on SQL. Okay. You cannot have a table containing the watch time of every user on a table. You don't care about whose watch time you are asking when you are talking about average watch time. You are talking about the aggregate of the column. You are not interested in the rows here. You are only interested in the overall column. So what Netflix will do is Netflix will have a watch time column. Suppose there is watch time column and there is user column, user ID. Okay. Now watch time might be an array, a long array. Imagine a long array which always contains the watch time for that day or whatever, or last hour or that day or whatever watch time is there. Okay. Now this array can be stored across multiple machines, and then you can do map or reduce on that operation. And there will be a server which will keep on fetching values from this array to get the average watch time of all the users in the world. Okay, so this array will be divided into multiple copies, and there will be a server which will fetch the values of which will do a map reduce over all these database, all these different database servers to get the average watch time of users. Does that make sense, Vivek? So suppose you want to find the age group which contributes maximum traffic on a specific website. Do we need some sort of relationship between the two columns? Suppose you want to find the average age which contributes to maximum traffic on a specific website. Let me understand this question. Let's talk about a particular website. Let's talk about whether you want to find the average age of group of users which have maximum watch time of Netflix. Suppose that is the question. Then what will you do is you will partition your watch time array into different partitions based on the age group. Okay, age group. So the first part will be 18 to 16, 18 to 25. The second partition will be 25 to 35. Third partition 35 to maybe 55, and the fourth partition 55 to 75. Now, Ekta, what you are going to do is you are going to save these different parts of this array into different servers. And then you are going to do queries on each of those servers to get the reply. Typically, there's a lot of partitioning that happens in these databases, and that happens based on the access pattern that you're talking about. Okay. When you design for a small application, these problems don't occur. When you design for large application like Netflix, partitions will come from SQL tables. No, partitions can happen in any database. This is Cassandra. Cassandra also have partitions. Cassandra is a column-wide database, and what you have is partitions are there also. Every database have some kind of partition. DynamoDB has it. I think MongoDB also have partitions. Whenever you want to, let me spend few minutes talking about partitions. Okay, this is a very important point. It performs same at Avijit. It performs at the same level at column wise as in SQL, but the thing is, you can scale the column wise database further. SQL cannot be scaled. That is the difference. Performance is same. Okay, Avijit. Column wise can be scaled because you can save each column into different server. Why do we need column? Because we want to do analytics. Because we want to do analytics on a huge amount of data, and we don't worry about each row. When we are doing analytics, we are worried about the column. Okay, Vivek, do you want to unmute? Okay, please unmute yourself. Let me see. Let his request come up. Yes, unmute. I cannot see your request, Vivek. Okay, I can see it now.
Yes, sir.
Yes, Vivek.
Sir, why do we need this column-wise and
suppose suddenly the Netflix stocks have fallen by 10%. Okay. In the stock market, suddenly Netflix stocks have fallen by 10%. Now, how will Netflix know that my stocks have fallen by 10%? It needs some kind of way of understanding what is happening with the business.
Yes.
So it wants to know how many people are watching my app, what is the time they are spending on my app, and what is going on in the industry, or what is going on with my users.
Yes, sir.
So it needs to find what is the average watch time of my users per day. Every day it wants to know what is the average watch time of my users. Is this clear?
Yes, sir.
But Netflix have so many users that their watch time cannot be stored in a SQL database. You remember I have talked about SQL databases that you cannot have horizontal scaling in them.
Yes, sir, but we can store using object now. So
you can store using object. That is a good option, good idea. For every user, what you can do is, for every user, you can have an object where there is a user ID. Okay. User ID, say 23, and there is a watch time. Okay. Watch time is say 45 minutes. Okay. Now what will happen with this? There will be multiple users which will be spread across multiple data, multiple machines. Okay. This table will be spread across multiple machines, and when you want to do analytics, you have to fetch all the users one by one from all the machines. Okay. Yes. And if you want to do analytics, suppose you want to fetch the users with age 45 only, like you want to edge users of age 45, then you have to go through each user in this machine, each user in this machine, each user in this machine. Every user you have to go through before you can get that analytics. Okay.
Yes, sir.
Now imagine how much time it will take, because you are going over each user every day. Okay. And you have lots of machines. It will take a lot of time. Okay. But suppose now what I do is I take a watch time array. I create a watch time array because I don't care about the user ID. As far as I am concerned, I am only interested in average watch time. I don't care who was the highest watcher in the whole list. Okay.
Yes, sir.
So what I can do is I can have an array which contains, for every user, it contains the watch time. Somebody watched for 45 minutes, somebody watched for 23 minutes, somebody watched for 54 minutes. And now I can just access this array in one go. I don't have to fetch so many objects. I can fetch the array in one go and I can say what is the average of this array.
Okay. And so what is the watch time means what?
Watch time is basically how much time you have spent on Netflix. Suppose you watch a movie of 3 hours, then your watch time will be 3 hours.
Okay. But we want to age, so...
Yeah, so that's what I'm coming to now. Now what you can do is, you can partition this array based on age. Okay? First you can sort the array. While saving this array, you can sort it based on age. Okay?
Okay.
So, if people with age 18 will come first. Okay? Then people with age say 21 will come. And so on and so forth. And what you can do is, while saving it in your partition it based on age. So all the people with age 18 will go into the first DB server. Okay? Or all the people with age 18 to say 25 will go into the first DB server. Okay, Vivek?
Okay.
Now, if you want to know what is the average watch time of people from 18 to 25, you just have to take one array from this server. And you can see how fast it will be.
Yes.
Because you are not making that many network requests. The problem with this approach here is that you are making as many users are there, that many network requests to all the servers.
Yes, sir.
But here you are just making one network request that is returning you the array. Sometimes it also don't return you the array. It just returns you the average of the array. Okay?
Yes, sir. Okay.
So that is the beauty of column-wide databases. Okay?
Yes, sir.
Does the column-wide databases make sense to everyone? Is there somebody who is not, for whom this is not making sense? Avijit?
Yes, sir. Clear to me. Thank you, sir.
Sure. But to update the average in real time, it will make more network calls. It will not make more network calls. It will send all the calls for a given age group in one go. For every updation, there will be one network call. Even here, that was happening. So that is not going to change, Avijit. Okay. Let me check. Suppose you don't find average. Does that answer your question, Ekta? Does the partition logic clear to you? Or do you want me to repeat the partition logic? There is this concept of partition. Okay. No, it is ended. Your call is ended. Your call is ended, Vivek. I'm not seeing it on my computer.
No, sir.
I'm also not able to end. Can you refresh? Let me refresh. Okay, now the call has ended. Very good. Sometimes there are problems with this app. So that's okay. So those were the key databases. There is, whenever you want to do a lot of analytics on a huge amount of data, you can use a column-wide database. Cassandra, HBase, Google Big Data, Big Table, all of them are examples of column-wide. So let me see where I have written that. Yeah, here. So column-wide is not SQL. They are Cassandra. You have HBase. You have Google Big Table. All of them are examples of column-wide databases, wide column databases. So those were the types of. There is also time series database. I'm not sure about that. Typically when you want to get the time series data, maybe stock market data or maybe click stream data, you can use time series for those kind of use cases. I've not seen any use case in industry right now. There might be some use cases, but I'm not sure about it. Let me see who uses time series databases. IBM uses There's one DB which is Influx DB, and IBM uses it. You will not see it in much. You will not see much fuzz about Influx DB. yeah, partition in little detail. We are going to come back to partition again and again in this lecture, but I still want to talk about partitioning because it's an important topic. Thank you, Abhijit, for pointing it out. So this is a general topic. Suppose you have bunch of, let's talk about MongoDB, and you have bunch of objects. There is a bunch of documents that you have. Okay, you have bunch of documents. This is doc 1, this is doc 2, and this is doc 3. Okay, now what will happen is, Abhijit, that you cannot store all the documents because you have millions of documents. You cannot store all the documents in one machine. This is the key fact that we started the class with. We started with the fact that we cannot store all the data in one machine, and it's very difficult to do joins on SQL databases. So we have to store the data across multiple machines. Now, there are very clear and very clever people in the industry who already thought that since we are already dividing the data into multiple chunks, why don't we do some interesting things so that we don't have to repeatedly access multiple machines for a single query. So what people do is they decide how they are going to divide their data across multiple machines. One way is to divide it based on ID. So you can basically divide, if the IDs are from 1 to 100 and you have 10 machines, first 10 IDs can go to the first machine, second 10 IDs can go to the second machine, third, and so on and so forth. 10 IDs per machine can go. But the problem with that is there is no, the data is randomly divided. You don't know how the access pattern will be. But suppose already you know that every time you want to access the data, you access it based on age. Okay, you access, most of the time you access the people from 18 to 25 together. Okay, Avijit. So what you can do is, just like in the previous example, you can divide the data based on the age. So people from 18 to 25 age will go into the first bucket. From 25 to 55 go in the second bucket. 55 to 100 go into the third bucket. Based on this, you can partition your data. And next time, you already know that you are going to get data for this group together. So you are going to access 1 DB at a time. That is the key funda behind partitioning. We'll come back to it again and again in this course when we discuss MongoDB. Okay, but that is how databases store value. So these kind of interesting ideas are what makes these databases run so fast. If you can design, if you can learn how to design good databases, uh, you can be paid a lot of money. Because these databases are not trivial to design. For small projects, they are trivial. It is very easy to design them. But for big projects, how can we learn that? Basically, you can watch some videos online. There are a bunch of good. Let me see if I can bring it up. There's one video that I'll recommend today, and it is something based on DynamoDB. So DynamoDB tutorial. No, not this. Not this. There's
अरे कुछ नहीं.
Hello, am I audible? Is this video stuck? Hello? Okay, okay, sure. My computer hanged for a few seconds. Sorry for that. Yeah, Rick Hollion. There is a okay. So I think I'm back. Let me paste the link to the video that I want you to watch. This is called Rick Hollion. He's from Amazon, and Rick Hollion is from Amazon, and he has a very good video on DynamoDB. Okay, so you can access, and if you learn about DynamoDB from him, you will learn about database. You will learn about how NoSQL databases are designed. Okay, so but that is for later. Like when you when you want to specialize in specialize in being database architect, then you can watch these kind of videos and these kind of people, and they will guide you into how to design databases for enterprise applications. But that is a long way to go. Like after 3-4 years you can watch it at least. Sharding and partitioning, yeah, it is similar. Yeah, sharding is where oh sharding is basically same as partitioning. Yeah, okay. uh Now let's go back to the lecture. Now in sharding, the other key thing that you change is basically similar to the hash maps. There is a uh, hash table that comes into picture, and what happens in sharding is uh, whatever age you give. Suppose you give age 18. For age 18, it will give you a partition number. Okay, and then what you can do is you can access people from age 18 from partition number that you're talking about. So it's a map. Sharding gives you a map between between the key and the partition number. Okay, this is what sharding do. Does that make sense, Abhijit? You have a bunch of partitions. You want to find the partition number of a key. You can map it to a map. You can use a map for that. Sometimes it is not as simple as storing the first 15 people in the first machine, storing next 15 people in the next machine, and so on and so forth. You need a mechanism. Without this, how else partition happens? No, partition don't happen without it. Partition need that kind of table which can give you the partition number. Okay, but I was explaining the concept of partitioning. Sharding means basically dividing. Okay, there are bunch of ways of sharding. You can do sharding based on columns. You can do sharding based on rows. You can do all sorts of sharding. Okay, and there's a table which remembers which rows goes where. Okay, sharding is a way to divide. Yes, it's a way to divide. Why do we need? Because okay, so let's spend some time talking about sharding. Sharding is a process of dividing where a big table can be saved in multiple machines, or maybe big table or make lots of data. Even when we talk about, since people have learned SQL so well, even when we talk about NoSQL databases, we use the vocabulary of SQL databases. Okay, so even when you talk about MongoDB, people usually talk about rows and items. Okay, rows and columns. So imagine you have a data set. The first is user ID. Second is name. Third is status, maybe married or unmarried, marital status. And there is a photo link. There are two ways you can sort this data. Either you can divide it horizontally. You can take this chunk and save it into one machine, and take this chunk, save it into a different machine. This is one way. The other way is you can divide it based on the columns. You can take these two columns, save it into one machine, and since this is your primary key, you can take this column along with this column, these two columns. You can take these two columns, save it in one machine, take these two columns, save it in another machine, and so on and so forth. You need a central table that remembers which column or which row went to which machine, and that is called as uh, your hash. That is called your index. You call it index basically. It depends on use case, Ekta. Sometimes dividing it based on columns makes more sense because you want to get columns. Sometimes when you're interested in each individual row, then it makes sense to divide it based on horizontal sharding. Okay, now you can divide this, and there's a machine which remembers there is a hash function basically that remembers which part of the table went where. Okay, there is a big table which just remembers which part. Give me the part number and I'll tell you. Dividing columns looks more like it should look more like column wide DB, Deepanshu. Okay, it should not look like relational DB. It should look like column wide DB. Okay, yeah. So there will be a table, I'll call it index, and that index will contain, give me the ID of the row and I'll tell you where it is. Or if it is vertically sharded, give me the column name and I'll tell you where it is stored. And that is what index will contain. So this is the mechanism used behind dividing the table. But the idea is basically the same. You want to divide the table across multiple machines and you want to do some interesting things with the division. We have discussed most of the databases and we have discussed the difference between them. In this, we are going to use MongoDB, which is something you should be able to understand now. In this project, we are going to use MongoDB. MongoDB is a document-oriented DB. MongoDB is a document-oriented DB, and it has certain features. You can imagine you are saving the objects that you are using in your machine directly into the database. That's the image I want you to have in your mind. All the objects that you are creating over time in your application, you are directly saving into the DB all those objects. Okay. First thing is, the rows don't have to have a particular schema. This is a schema less DB. There is not a requirement to have a strict schema. Now you can have hierarchical data. You can store hierarchical data in MongoDB. What that means is you can save an object which contains a smaller object inside it. You can save XML files. You can save JSON files. You can save all that in MongoDB. And the beauty about MongoDB is if tomorrow your CRM app goes viral and it is available across the world, MongoDB can scale your app to a huge number. MongoDB can scale. How to know if our app won't require schema? Typically when you're building a new startup, you don't know if it's schema less, then how to access data. Then you can just send the ID of the data. So we are going to discuss about the data model in more detail, but typically what happens is there is a primary key which is constant across every file. So every document that you save should have a primary key, and then you can access the document using the primary key, Gauri. Okay. You can know when your app will not require a schema when you know that you are not sure about the features that you are building. So this is another point that I want to make. You know about agile development? Okay. Suppose I want to build a car. How am I going to build a car? One way is to have a blueprint and design each part and then build all the part into a big car. That is one way, which is a waterfall method. Okay. Most of the physical things are built using waterfall development. You decide what you want to build, and then you build it across. Suppose you want to build a bridge, you build a bridge and directly work from. You build a design, then you decide on each of the calculation, what will be the load, and then you can build the bridge. That is called as waterfall development. Design, develop, test, ship. Okay, this is a single direction. This happens in single direction. But with agile development, what happens? You launch a very MVP app. You launch a very basic app. Okay, you design, then you develop. Sorry, this is hanging. Okay, I'm coming to that, Vivek. You design, you develop, you test, and you design further. When you have this loop going on, which will happen a lot in software development, a software is never complete. Either it is legacy or it is a new software. If a software is new, you will keep on designing and developing at the same time. When this happens, you don't know what is the next feature the design team will ask you to build. And in that case, you cannot be strict with your schema. Okay, Avijit? But halfway into the project, if we realize it can be a mess, that's where you have MongoDB. Yeah, that's where you have MongoDB. You can start off anew. You can start saving a new schema for your table. You just have to make sure that the key ID is same as what you are started out with. Okay. All those messes happen, but a database take care of it. You can fill the values back into the database. So, apart. No, apart from is better. Yeah, mostly it's better, but yeah, it's mostly better. Have you ever heard of MERN stack or mean stack? The reason why MongoDB is constant across these stacks is because of these properties. Most of the internet-based companies can directly use MongoDB and it will work well for them. Okay. Now I'll go to Vivek. What is MongoDB? MongoDB is a database object I've written here. It is a document-oriented database. Do you know what document-oriented databases are, Vivek, now? Okay, so this is a document-oriented database. That's what MongoDB is. The key property about MongoDB, what is document-oriented database is a NoSQL database where we store the documents. You remember a database where I was storing objects into the database directly? The difference between MongoDB and SQL database is basically MongoDB you can directly store objects. In SQL you can store tables. MongoDB can scale, SQL cannot scale, and MongoDB is eventually consistent and SQL is always consistent. Does that make sense, Vivek? It will become more clearer between sir, but SQL also, so you can save objects, but it cannot scale. It cannot scale that much. Okay, it cannot scale across horizontally. I mean, you need a lot of development to scale SQL databases, and they are very expensive to scale because they need a lot of manpower. It's not trivial to scale a SQL database. Anyways, so what is so basically what will happen is you will save JSON files directly into your DB, and each file will have a ID field which is required so that whenever you want to fetch that file, you can access the ID. A bunch of uh, documents together are called as collection, and you can access a collection. So collection is very similar to table. Remember table in SQL in DynamoDB, they are called as collections. And you already know about documents. There are fields inside the document. Suppose this is the document. Suppose this is XYZ. What is schema less means? It means there is no set pattern that you have to follow. You don't have to have a row with 4 columns. You remember in SQL, if you send a half row, like if you want to insert a row without 2 values, then it will give an error because it will say I cannot find these 2 values in your table. If those values are required, if you don't save the foreign key or if you didn't save a particular key, it will give you an error. So that is called as a schema. If you want to save, suppose there is a table, student table, and there is a name, there's a roll number, and there is age. Okay, so this is the schema. You are going to save these 3 things about the student. But suddenly, if you want to save this class or class of the student, there is a problem. You will have to change the schema of the table. Whereas in MongoDB, what you can do is you can start saving class afterwards. Some of the students will not have class, some of them will have class. And that's okay with you because you don't care about the schema of the table. In MongoDB, we can create our own schema. Yes, you can create your own schema while saving the document. You can, as long as the document has the ID and some more basic checks, you can save whatever you want to save in the document. That has its own benefits and losses, but mostly there are benefits with this. Okay, that is called as schemaless. MongoDB is very famous with internet-based applications because it provides some basic fundamentals. You can do, it's document oriented, so it's very fast to fetch a particular document. Ad hoc queries like range query, regular expressions, all those kind of analytics can be done on this. So it's good for analytics. There's indexing that you can do. So you can decide which way you want to index your DB so you can get it faster. you can get the answers faster. I'll discuss indexing in more detail in coming lecture, which is very similar to the sharding method that I've talked about. I've talked about sharding. Indexing is a concept similar to sharding, but I'm going to discuss that in more detail in coming lectures. But basically, the idea is you can index the database based on a particular number, particular field, and then when you access something depending on that field, you can get it very quickly. This has yes, okay. This has a very good availability requirement. Like with internet applications, the key requirement is that you want your application to be available all the time. So MongoDB applications are usually available. They always take the right request, and you can write anytime. It is eventually consistent, so values will go to the go to the ultimate value slowly, but not always. Sharding uses hash map. Sometimes it uses hash map. Availability depends on availability depends on how you are locking the database. Are you locking the database, or you are accepting writes all the time? So for example, SQL databases will lock the whole database before writing something into the database. In MongoDB, you don't want to log the database. You can keep on taking write request all the time, and then later on you can figure out which was the final value. For example, if you are taking likes on a tweet, what will happen is you can take likes from all over the world, and then later on you can figure out what was the total number of likes. Okay. Sharding can use hash maps. It can also use ranges. So we'll discuss more about indexing and sharding in upcoming lectures. Okay. Ekta, your question. Yes. How much in-depth knowledge related to sharding, indexing, partitioning do we need for the CRM application? Not much, Ekta. That is the beauty of MongoDB. You don't need to know a lot of things. Mostly what we will discuss in this class will be all the knowledge you need. Okay. Basically, these things become more important when you have a huge scale requirement. When the scale is very big, you'll need all these information. How is inconsistency taken care in MongoDB then? It is taken care later on. Later on, all the servers will communicate with each other and will try to find what is the final answer. So there are different ways of dealing with inconsistency. Suppose five servers says the maximum count is 4. There are 5 servers. 3 will say that the max count is 5, and 2 will say no, max count is 4. We can take the majority vote and we can say 5 is the final value, and everyone will say 5 then. Okay. So all those kind of methods, like there are different algorithms that follow. Sometimes they do majority voting, sometimes they do other algorithms, but these inconsistent. So for your knowledge, all you need to know is that inconsistencies will be taken care of in the longer run. Okay. Yeah, it happens different ways based on the algorithm that the DB follows. Okay. Yes, Ekta, you will not need a lot of knowledge, but as you become a senior developer, you will gain these knowledge about databases. It's highly paid knowledge. Like it's very valuable knowledge that you can get. Okay. Any other questions? We are going to discuss MongoDB in coming lectures. For like 3-4 lectures, we are going to discuss MongoDB. Let me see the plan. We are going to discuss MongoDB for 3-4 lectures, and then we'll start building the app directly from MongoDB itself. But then after some time, we'll start building different features of the app. So next 4 lectures, we are going to discuss about MongoDB, and then we are going to use user registration and login. We'll build the user registration and login. We'll build authentication. We'll build user activity, ticket manipulation, and finally we'll do unit testing. How to do last 2 point, replication and load balancing mean? Replication and load balancing means replication is the same idea. Like availability is what replication is all about. You want your data to be available, and load balancing is saying that while you have multiple databases or multiple servers, you want to make sure that the load on each of those servers is equal. You don't want to make a case where one server is highly loaded and other servers are not that much loaded. So that is called as load balancing. So I'll discuss let me discuss load balancing for 2 minutes. Suppose you have 5 servers. They are doing the same thing. They are serving a client. Okay. So what you typically have is a load balancer, which is a machine in itself. And before request going to the server will come first to the load balancer, and this load balancer will know how many requests are there on each of the machines. Machine 1, machine 2, machine 3, and machine 4. And this load balancer will decide where to route the request, whether the machine 1 should answer the request, machine 2 should answer, machine 3 should answer, or machine 4 should answer. Okay, if there are copies of same data across multiple machines, load balancer will decide where to send the request. That is the part of load balancer. Okay. Yeah. One question, but unrelated. Yeah, you can ask Avijit. Please go ahead. Replication is why did we use SQL DB in e-commerce app then? Because you cannot learn all the things in one go. Vijit, because we cannot teach seems NoSQL would have been better. Yeah, that is true. But you cannot learn NoSQL without learning SQL. First, you should have some knowledge about SQL. Okay, and we cannot teach you everything in the first app itself. Therefore, this is the second app. Okay, what is replication? Suppose one of these server goes down. Suppose M1 dies. There was a hardware failure and M1 went off. Then what will happen to the data stored on M1? Are you okay to lose the data of 25% of your users? No, you don't want to lose the data. So what you will do is you will design another server which will have a copy of M1. So I'll call it M1 dash. And some of this data will be saved there also. And this idea where you are saving the same data across two servers is called as replication. You want to make sure that all the data is not lost once there is a server down, once the server is down. Okay. Yeah. Now they have different ways of getting data from servers which are down also. Suppose there is a hardware failure. In that case also they can retrieve a lot of data from the server. So yeah. Typically, it happens in the hardware that you don't lose the disk itself. You sometimes lose a motor or something. So you can get the data later on. But still, you want to have 2 copies of the data so that you can make the users online immediately. So that is what replication is about. Okay, that's it for today's class. If you have any more questions, you can ask. Otherwise, we can end the class. What is RAID for disk? We use RAID for disks. What is RAID? What is RAID? I don't know about RAID. RAID. Oh, that is virtualization. Okay, it's used for virtualization. Yeah. I am not sure about that, Archit. I'm not sure about that technology. Sure. Any other resources to refer? No, I think that you can search about this guy, Julian. You can search about this guy, Julian, and he will be a very good resource. It's very difficult to come up with good resources for these things. Whenever I come across a good resource, I'll again mention it in the class. But Julian is a very good resource. Okay. Thank you, students. Hope to see you on Monday. Bye, everyone. Bye-bye. Have a good day. Happy weekend.